Thank you, Ashish. Studying second year in EC department of third sem. Now I would like to talk about my TikTok topic of subject signals and stochastic process. And the topic name is Adaptive Secure Transmission for Wireless Powered Communication Networks. Introduction to powered communication networks which are wireless. Wireless powered communication networks WPCNS utilizes energy harvesting to power devices. These networks are enable devices to operate without traditional battery constraints. The integration of adaptive secure transmission and enhances the overall security and efficiency of these networks. This introduces the wireless powered communication as a promising paradigm to overcome the energy bottleneck suffered by traditional wireless. It selectively spans a coherent spectrum of fundamental aspects in WPCA, such as wireless energy transfer techniques, radio frequency, energy harvesting, receiver model, stimulates wireless information and power transfer as well as the rate energy trade-off arising from the joint transmission of information and energy using the same waveform. And this further examines the key factors of including throughput, fairness, and security that must be taken into the account for impeccable operations of WPC to the new IoT applications are targeted as the key element in those factors. This is the introduction to wireless powered communication networks. And the key components of wireless communication networks are the essential components including the energy transmitters, energy receivers and communication nodes. Energy transmitters provide power wirelessly, allowing devices to harvest energy for operations. Communication nodes facilitate the exchange of information while ensuring the energy efficient operations. Here we can see the energy source, transmitter, messages, receiver, and power to load. Here we can see in transmitter we have control, communication, and energy converting circuits. And further it moves as message to the receiver and it contains control, communication, energy converting circuits. And output is to power to load. Now the importance of adaptive secure transmission. Adaptive secure transmission techniques are designed to enhance data security in wireless networks. These techniques adjust transmission and parameters based on the environmental and user-specific factors. The steady growth in wireless communications are fostered by the prosperity of mobile services as result in unprecedented awareness of the potential of physical layer security to significantly strengthen the security level of current systems. The fundamental idea of PLS is to exploit the inherent randomness of fading and interference of wireless channels to restrain the amount of information that can be gleaned to the bit by a passive eavesdropper. Although having been studied extensively in various kinds of networks such as wireless sensor networks, cellular networks, cognitive networks, is to fair acknowledge that the practically of PLNs in wireless powered communications is still an open problem. Now, let's see the challenges faced in wireless powered communication networks. They face a unique challenges including the limited energy sources and fluctuating channel conditions. Security vulnerabilities arises due to the open nature of wireless communication. Ensuring the reliable data transmission while maintaining security is a critical concern. Here we can see the challenges and opportunities for women's engagement in the clean energy sector. Only four countries worldwide have female ministers overseeing national energy policies and programs. More than 50% of premature deaths due to the pneumonia among the children under the 5 are caused by the particular matter soot inhaled from household air pollution. Here we can see the challenges faced through the wireless powered communication networks. Moving on, we have adaptive transmission techniques. Adaptive modulation and coding schemes can optimize data rates based on the channel conditions. These techniques allow for dynamic adjustments to enhance transmission reliability and security. By adapting the transmission and strategies, networks can better manage interference and eavesdropping risks. Here we can see the cryptography works. Plain text, readable format and non-encrypted data. From then to encryption and ciphertext, non-readable format and encrypted data, and then decryption take place and plain text, readable format, non-encountered, encrypted. Security threats in wireless powered communication networks. Common security threats include eavesdropping, jamming, and denial of service attacks. They operate the open nature of wireless communication makes WPCNs particularly susceptible to those threats. Adaptive secure transmission strategies aim to mitigate these vulnerabilities efficiently. Common security attacks in the OSI layer model. Here we have attacks like exploit, hijacking, DOS, man in the middle, spoofing, and etc. These are the security threats in wireless powered communication networks. Now let's talk about cryptographic techniques for security. Cryptographic techniques such as key agreement and encryption plays crucial role in security transmissions. These techniques can be adapted based on the energy availability and channel conditions. Here we can see the previous format of cryptography: plain text, encryption, then ciphertext, and then decryption takes place, and then plain text, which is in the format of readable and non-encrypted data. The integration of lightweight cryptography is essential for energy-constrained devices. These techniques can be adapted based on the energy availability and channel conditions. And the encryption plays crucial roles in security and securing transmissions. And then this examine the current research to provide an unified view of wireless power transfer and information transmission in WPCNs from a PLS perspective, focused on designing the efficient secure transmission schemes, analyzing energy evolvement processes, and evaluating secrecy outage performance under the different channel state information CSI. The results presented in the book shed light on how to best balance security and throughput with prudent use of harvested energy in WPCNs. From the IoT point of view, this highlights the opportunities and challenges for the lately emerged WPCN to seamlessly integrate into the emerging IoT ecosystem. Moving on, now we will have about energy harvesting and security trade-offs. Energy harvesting introduces of between energy consumption and security. Devices must balance the need for secure transmission and the energy available for operation. Adaptive strategies can help optimize the balance to enhance overall network performance. This could not be complete without contribution of our graduate students in the Wireless Communication Network Lab, Center of Excellence in Telecommunications, and the University of Sydney. They have done an experiment in their university to know more about the WPCNs. It specifically addresses the maximization problem of uplink and downlink sum throughout in a dual hope. WPCN, while taking fairness among WPCN users such as a constraint, this result while taking fairness among WPCN's users. The result in provided in the book reveals the valuable insights in improving the design and deployment of future WPCNs coming up in the IoT environment. Now let's see about performance metrics. Key performance metrics in adaptive secure transmission include throughout latency and energy efficiency. Evaluating these metrics helps assess the effectiveness of adaptive strategies in WPCNs. Continuous monitoring and adjustments of these metrics are crucial for optimal performance. The future directions of research. Ongoing research focuses on developing more and robust adaptive secure transmission protocols. Future studies may explore AI-based techniques for real-time adaptation to dynamic environments. Enhancing the resilience of WPCNs against emerging security threats will be a priority. Machine learning for self-guided learning, kinesthetic in learning in AR, remote learning in AR, real-time touchless and handless interaction. Here comes the conclusion of our topic. Adaptive secure transmission is vital for success of wireless powered communication. Sorry. By addressing security challenges and optimizing energy use, this can perform efficiently. The continuous evolution of technology will further enhance the capability of security of WPNs. So this is how the confidential information goes from the sender, and the jamming takes place in between the receiver which goes through the channel. So this is how it works, and the adaptive secure transmission is vital for the success of wireless powered communication networks. Thank you.